the universe has always fascinated humanity. For thousands of years, we've gazed up at the night sky, wondering about the vastness and mystery that lie beyond our world. From ancient civilizations to modern scientists, the question of the universe's origin has been at the forefront of human curiosity. The current narrative, backed by decades of research, has been that the universe began with the Big Bang, an enormous explosion around 13.8 billion years ago that created all of space, time, and matter. Over time, galaxies, stars, and planets formed, and here we are today, looking up and asking even bigger questions. But what if everything we thought we knew about the universe was wrong? What if the Big Bang Theory, long held as the definitive explanation for the birth of the universe, is only a part of a much more complicated, more fascinating story? What if the real truth is something so mind-bending that it changes everything we know about the cosmos? Enter the James Webb Space Telescope, JWST, the most advanced space observatory ever created. The telescope, launched in December 2021, is an international collaboration between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. With its state-of-the-art instruments, Webb is capable of peering into the depths of space with incredible precision, unveiling the universe's most profound secrets. Its infrared capabilities allow it to observe objects and phenomena that were previously impossible to detect, such as the earliest galaxies, the formation of stars, and the atmospheres of distant exoplanets. The scientific community had high hopes for JWST, expecting it to push the boundaries of our knowledge about the universe. What no one expected was that Webb would uncover so many mysteries that seemed to directly challenge our long-established cosmological models. The discoveries Webb has made are nothing short of revolutionary. For decades, scientists have held fast to the belief that the universe followed a predictable trajectory, one that began with the Big Bang and unfolded according to established physical laws. But as Webb's infrared camera captured deep space images, it quickly became clear that this conventional model might need to be reconsidered. The telescope has revealed galaxies that are far larger, far more complex, and far older than we ever thought possible. These findings have raised serious questions about the validity of the Big Bang Theory and whether the standard model of cosmology can truly explain the formation and evolution of the universe. One of the most significant breakthroughs came when Webb's near-infrared camera, NIRCam, observed a region of space near the Big Dipper, an area that astronomers had previously studied with other telescopes. Webb's advanced instruments provided a much clearer and more detailed view of this distant patch of the sky, and what they found shocked the scientific community. In the images, researchers detected 6 faint, reddish points of light. These weren't ordinary stars, they appeared to be galaxies. However, these galaxies were unlike anything scientists had predicted. Based on the redshift of the light from these objects, researchers determined that the galaxies were located over 13 billion light-years away, meaning they formed just 500 to 700 million years after the Big Bang. What made these galaxies so surprising wasn't their age, but their size. According to the prevailing cosmological models, galaxies in the early universe should have been small, baby galaxies, if you will. In the first few 100 million years after the Big Bang, there wasn't enough matter to form large, complex galaxies. Yet, the galaxies Webb detected were massive, some contained more than 10 billion solar masses of stars. One of them was so large that its stellar mass exceeded 100 billion solar masses. The idea that such massive galaxies could form so quickly, when the universe was still in its infancy, flew in the face of everything scientists thought they knew about galaxy formation. The discovery left astronomers perplexed. How could such massive galaxies exist so soon after the Big Bang? To explain this, researchers have been forced to reconsider the fundamental assumptions of cosmology. Could the early universe have been much denser than we thought? Perhaps the conditions in the cosmos during this time were vastly different, allowing for the rapid formation of large galaxies. Or maybe these galaxies formed through mechanisms we haven't yet observed, processes that are still hidden in the vastness of space. This discovery didn't just present a new mystery, it posed a direct challenge to the established models of cosmic evolution. If galaxies like these could exist in the early universe, then what else might we be getting wrong? The mystery deepened further with the discovery of another extraordinary galaxy, named Jade's GSZ 14D0, which Webb detected just a few weeks after the initial breakthrough. This galaxy, which existed just 290 million years after the Big Bang, became the oldest galaxy known to science. What made this galaxy even more remarkable was its luminosity. Despite the fact that it existed when the universe was still in its infancy, the galaxy was already emitting an immense amount of light. Not only did this suggest that the galaxy was much older than previously thought, but it also raised another profound question: how could such a massive, luminous galaxy form in just 290 million years? Researchers quickly began analyzing the data to understand the galaxy's structure. What they found was equally astonishing. This galaxy already contained hundreds of millions of solar masses of stars, and its spectrum revealed that it had undergone several generations of massive stars, which had gone through their life cycles and exploded in supernovae, enriching the galaxy with heavier elements. The implications of this discovery were enormous. The rapid formation of such a massive galaxy defied the conventional models of star formation and galaxy evolution, suggesting that something fundamentally different might have been at play during the early stages of the universe. With each new discovery, the puzzle grew more complex. The more Webb observed, the more astronomers realized that the early universe might not have followed the trajectory predicted by the Big Bang theory. These findings have led some scientists to question whether the Big Bang theory, in its current form, is enough to explain the origins and evolution of the universe. The idea that these massive, luminous galaxies could form so early in the universe challenges the very heart of our understanding of cosmic history. If our models of galaxy formation are flawed, what does that say about our theories regarding the universe's birth? For decades, the Big Bang theory has been the dominant explanation for the universe's origins. It has withstood numerous observational tests, providing a coherent framework for understanding the evolution of galaxies, the cosmic microwave background radiation, the redshift of distant galaxies, and the abundance of light elements like hydrogen and helium. But as Webb's discoveries continue to pile up, some scientists are beginning to wonder if there's more to the story than the Big Bang alone. Could it be that we've been looking at the universe through the wrong lens all this time? Perhaps the truth is far stranger and more complex than we can imagine. Some researchers have proposed alternative models that could explain the anomalies Webb has uncovered. One such theory is the concept of a big bounce. According to this idea, the universe is not the product of a single Big Bang, but rather part of a cyclical process of cosmic birth and death. In this scenario, the universe undergoes a never-ending cycle of contraction and expansion, with each cycle beginning with a bounce rather than a singular explosion. This model could explain the formation of galaxies like Jade's GSC 14D0 by suggesting that the conditions in the early universe were radically different from what we currently understand. While the Big Bounce remains a controversial hypothesis, it is one of the many theories that could potentially explain Webb's groundbreaking discoveries. Another idea gaining traction is the theory of the multiverse. According to this concept, our universe is just one of many, each with its own set of physical laws and constants. In this scenario, the Big Bang might not have been the beginning of everything, but simply one chapter in an ongoing cosmic story. The multiverse hypothesis suggests that our universe could have emerged from a collision with another universe or through some other process that we don't yet fully understand. This idea could potentially explain the strange structures Webb has discovered, as it allows for the possibility of a wider range of cosmic histories and outcomes. Yet another possibility, as proposed by physicist Nikodem Poplawski, is that our universe could have originated inside a black hole. According to Poplawski's hypothesis, our universe may be the product of a primordial seed that formed in the heart of a massive black hole in a previous universe. When the black hole's singularity collapsed, it created a new universe, which expanded and developed into the cosmos we observe today. In this scenario, black holes could serve as natural gateways between different universes, suggesting that our cosmos might be just one part of a much larger multiversal structure. While this idea is still highly speculative, it is an intriguing possibility that could help explain the strange and unexpected discoveries that Webb has made. Despite these new theories, many astronomers still maintain that the Big Bang theory is the best explanation for the origin of the universe. According to this view, the formation of galaxies like Jade's GSZ14D0 can still be explained within the framework of the Big Bang, though it may require some modifications to our understanding of the early universe. Some researchers suggest that large black holes could have formed in the early universe, creating powerful gravitational forces that triggered bursts of star formation. Alternatively, the rapid formation of massive galaxies could have been driven by supernova feedback or other processes that we have yet to fully comprehend. These possibilities highlight the complexity of the universe's early evolution and underscore the fact that we still have much to learn. Regardless of which theory ultimately proves correct, the discoveries made by the James Webb Space Telescope have fundamentally altered our understanding of the cosmos. Webb's observations have revealed a universe that is far more complex, more varied, and more mysterious than we ever imagined. Each new discovery challenges our assumptions and opens up new avenues of inquiry. The early universe is no longer a distant, hazy memory, but a place we can now study in incredible detail. With every breakthrough, we come one step closer to answering the age-old questions: how did the universe come to be? And what lies beyond the limits of our understanding? One thing is certain, the journey to uncover the truth is just beginning. And who knows? Maybe the next discovery from Webb will be the one that changes everything once again.